finally, let's go ahead and talk about the integral test, and you'll see much more writing on my paper than yours. Let me talk about it first before you start writing all this stuff down. Basically, a couple things. Number one, the integral test is one of the tests that you are only allowed to use when, let me widen this out a little bit. It is one of the only tests you're allowed to use only when all of the terms in the series are positive and decreasing. Okay, positive and decreasing. Got it? If they're positive and increasing, then you would have caught that anyway by the nth term test. Because if the terms are increasing, if the limit's not zero, then you have a divergent series anyway. So you wouldn't even get to the integral test if the terms were positive and increasing. So anyway, the terms though do have to be positive, they have to be decreasing. In other words, as n gets bigger, the value of the term gets smaller. Okay? So, that being said, let's look at this particular example right here, and which is really one of the only examples I've ever seen in which you would have to use the integral test. So you're not going to use the integral test very often, but once in a while you have to. So it's one of those feathers in your cap, okay, if you will. So the bottom line is this. The integral test says that if you take, basically you take your a sub n, your nth term, and you convert this nth term to a function of x. Okay, so if you let a sub n be f of n, just like this, like we have this series right here from n equals 2 to infinity of 1 over n ln n. Okay, well I just, instead of using the summation notation, I use an integral symbol, and I went from 2 to infinity just like you see here, and instead of an n here, I put an x here. So we change the nth term to our integrand with x's in it, and basically if this integral converges, then the series converges, and that's what this says here. So basically if the integral converges, then the series converges, and likewise if the integral diverges, then the series also diverges, and that's the integral test. I just went ahead and did this example. If this were in fact the series that we were wondering about, then we convert it to an integral, which means we have a limit because we have this infinite limit of integration. So we send b to infinity and we integrate from 2 to b. We have to use the u substitution. This has everything in it. The u substitution, and then we get 1 over u. We convert it back to ln x, and we see we get, as b approaches infinity, the ln of b. Okay, minus some other stuff. This is a constant. But the ln of b, as b approaches infinity, the ln of b approaches infinity, and the ln of infinity approaches infinity. So basically, this integral diverges, therefore the series also must diverge based on the integral test. And that's how you would say it. We may be able to do another example in class. Hopefully we'll be able to find a couple more series that we can use just the integral test for. But I do want to reiterate two things. Number one, you're not going to use it very often, but you're only allowed to use it if all the terms are positive. Okay? So if it's an alternating series, any term is negative, you can't use the integral test.